What we're doing is stoichiometry, and what that is using conversion factors in a balanced chemical equation to determine the amount of reactants or products needed and expected in a reaction. So how do we do that? Let's see with this problem right here. So what we have here is an unbalanced chemical equation. We have B2H6, which reacts with oxygen gas to produce HBO2 and H2O, which is basically water. So what we need to do first is to balance out this chemical equation, because the only way you're going to do stoichiometry is when it's in a balanced equation. So what we have here, we balanced it out. So we have 4 atoms, or also 4 moles of B2H6, which reacts with 12 atoms of oxygen gas, which produces for us 8 HBO2 and 8 molecules of water. So we have it balanced out, right? Number 2, we have to set up our GCD format. And our GCD format is our given, desired, and conversion factors, which is also going to be our mole ratio. I'll get to that in a minute. So basically, the GCD, that comes into our second step, and that is to determine the desired and the given. With the desired and the given, the desired is what we want to figure out, and the given is what we have in the problem. So what we want to do is determine the mass of oxygen gas with 36.1 grams of B2H6. That's what we have. Now, number 3, we need to find out our mole ratio. Our mole ratio is going to be this right here. And basically, we have 4 moles of B2H6 equals 12 moles of oxygen gas. So basically what we're going to have right here is we're going to have whatever you have right here for your given, those are the atoms you're going to use. And whatever you have in your desired, that's the atoms you're going to use as well. So what we have right here, we're going to start with unit cancellation. And as we go, we're going to convert grams of B2H6 to the moles. Then once we get to the moles, we're going to get to oxygen, and then once we get to the oxygen gas moles, we're going to get to the molar mass of that. And then all in all, we're going to be able to work it out. So now that we've finished doing the work, we finally see what our unit cancellation looks like. And basically, we have everything worked out, but what we want to do is cancel our units so we don't get confused when we're doing the math. So what we have is 36.1 grams of B2H6 and 27.68 grams of B2H6. Since that's on the bottom, that's on the top, you're going to slash those 2 units out. And then what you have to get oxygen, right? So you're going to use 1 mole of B2H6, and on the bottom is going to be 4 moles of B2H6. You're going to cross those 2 out, because now you have 12 moles of oxygen gas. So after oxygen gas, you got to find the mass, right? So what you're going to do is 12 moles of O2 and 1 mole of O2. Now that you have the moles canceled out, now you have the mass, the grams, and that is your desired. Now we're going to do the math real quick, and basically what this comes up to is on the bottom. You want to do the bottom first because you're going to save the number for later. So from the math on the bottom, 27.68 times 4 is going to be 110.72. And on top, we're going to do the math right here. So we're going to have 36.1 times 1 mole B2H6 times 12 times 32 grams. So basically, that's going to equal 13,862.4. So now we have our fraction. We have everything that we're going to work out, right? So we're going to divide that, and we're going to come out with 125.202 grams of oxygen gas. That is what our problem is going to look like. However, never forget, we also have significant figures. So what we have right here for 36.1. So for 36.1, basically what we have is 3 sig figs. So when you divide it, you cross it out. So that leaves us with 125 grams of oxygen gas.